In June of 1995, the Space Shuttle Atlantis docked with the Russian space station Mir. It was an historic first for both the Russian and American space programs. From an engineering and design point of view, it was also surprisingly easy. Questions were asked about how these two competing space programs could have such compatible technology. Suspicion fell on the now abandoned Russian space shuttle called the Buran. Even to untrained eyes, the two space shuttles were remarkably similar. The Buran had been designed to dock with the Mir space station, but with the fall of the Soviet Union in 1991, the project was shut down. As authorities began to take a closer look at the Soviet shuttle and its suspiciously American docking system, they discovered a KGB plot to steal US technology, a murderous love triangle, and a double agent selling secrets. In 1969, after the US had won the race to the moon, President Richard Nixon brought together a panel of experts to decide what was next for the nation's space program. The group produced a report called The Post-Apollo Space Program: Directions for the Future. And in 1972, Nixon directed NASA to begin development of the Space Shuttle. The Space Shuttle was supposed to be a reusable space truck, a profit-making, economical spacecraft intended to make spaceflight easy and accessible. This was hardly a new idea. The Soviets had also been exploring a reusable spacecraft, but when the US Space Shuttle program was announced, the Soviet military became suspicious that it could be used for military purposes. And they weren't wrong. The US Air Force was heavily involved in the development of the Space Shuttle, and their requirements, mostly surrounding the deployment and retrieval of military satellites, influenced the Space Shuttle's design. Soviet military leadership believed they needed a competing program. In 1974, leader of the Soviet Union Leonid Brezhnev had a meeting with a man called Leonid Smirnov. Smirnov was the head of the Military Industrial Commission, also known as the VPK. In the meeting, Smirnov outlined the US Space Shuttle program. He told Brezhnev, "The Americans are intensively working on a winged space vehicle. Such a vehicle is like an aircraft. It is capable, through a side maneuver, of changing its orbit in such a way that it would find itself at the right moment, right over Moscow, possibly with a dangerous cargo." When the head of the Soviet military, Marshal Dmitry Ustinov, a hardline communist and Cold War enthusiast, got wind of the US plans, he fully backed a Soviet response. The Minister of Defense at the time, Andrei Grechko, was less enthusiastic and balked at the amount of money that would be required to get a competing space shuttle into production. Smirnov and the VPK, however, stoked the flames of Cold War paranoia, and an aging Brezhnev greenlit the Soviet shuttle project. In February 1976, a decree authorizing the project was finally signed. The Minister of Defense and the project's most high-profile critic, Andrei Grechko, had died and been replaced with warhawk Dmitry Ustinov. The administrative hurdles had been overcome, but there were significant logistical hurdles ahead, with the key issue being the fact that the US now had a 4-year head start. And at this point, a design for the Soviet shuttle hadn't been settled on. 10 years earlier, in 1965, the Soviets had begun working on a reusable spaceplane called the Spiral, a small but efficient orbital spaceplane. The project was shelved in 1969, but engineers proposed going back to the Spiral design as a basis for the new shuttle. The Spiral had been in development for years, so designers and engineers wouldn't have to go back to the drawing board and could potentially catch up to the US. But in a display of the kind of competitive tit-for-tat that was all too common during the Cold War, this was quickly rejected by military leaders. Not because the Spiral was an inferior project, but because it was not at all similar to what the US was doing. The Soviets, however, did have another means of closing the gap: the VPK. The primary function of Leonid Smirnov's VPK was coordinating all Soviet military research and production, and importantly, overseeing the collection of vital resources, including scientific and technical information. Each year, the various departments of government would deliver to the VPK a wish list of Western technical or scientific information that they would like access to. The VPK in turn would assess the list and assign the Soviet intelligence agencies, the KGB, and their military equivalent, the GRU, various clandestine missions to retrieve the required information. One example of the VPK at work was the Tupolev Tu-144, the world's first commercial supersonic transport aircraft. In the 1960s, the Soviets had gathered critical design data by spying on the British-French Concorde and the Boeing 2707. But according to CIA documents, the Soviets couldn't take full advantage of the data, and the Tu-144 was not commercially viable. But when it came to the space shuttle, the United States gave the VPK an unexpected helping hand. The United States decided not to classify its program. All the technology that would go into the shuttle would be unclassified and freely available if you knew where to look. The problem was managing the amount of data that was available. Between NASA and the thousands of institutes and private sector subcontractors that had input into the program, the United States was churning out reams of material both in hard copy and in digital form. According to CIA documents, the KGB had a division specifically focused on the acquisition of Western strategic, military, and industrial technology called Directorate T. Directorate T had approximately 1,000 agents, with 300 of them on foreign assignment. These field agents were known as Line X. They were science specialists that would often have cover assignments at Russian embassies, in trade delegations, or in academic institutions. The CIA estimates that in the late 70s alone, the Soviets obtained over 30,000 samples of Western equipment, weapons, and military components, and over 400,000 documents, both classified and unclassified. Initially, the espionage was happening in plain sight. Soviet agents would search public databases for the reports they needed, then walk from the Russian embassy in Washington, D.C. to the government printing office on North Capitol Street. There, they paid their money and took the documents back to the embassy.
We've gone for main engine start. We have main engine start. America's first space shuttle. And the shuttle has cleared the tower.
When the first fully functional American space shuttle, Columbia, launched in 1981, there were 3,473 documents online relating to the shuttle in general. 364 on wind tunnel tests, 103 on the shuttle's booster rockets, 124 on heat-resistant tiles, 605 on the shuttle's computers, and even 10 on its military applications. Intelligence officials estimated that the Soviets had saved billions on their shuttle program through espionage. The Soviets didn't have to put their orbiter through wind tunnel tests and computer simulations, as all the US test data was available to them. Superficially at least, the space shuttle design was so well known that even Hollywood was able to make their own version. In 1979, the James Bond film Moonraker proved that art imitates life. The film opens with the theft of a space shuttle called Moonraker, whose design is remarkably similar to the real space shuttle. The fictional Moonraker was used for the very thing the Soviets feared: transporting weapons to space. The Bond villain Drax used a fleet of Moonraker shuttles to deliver a deadly nerve gas to a hidden space station where he intended to launch the gas into the Earth's atmosphere, wiping out the human population. Moonraker was released 2 years before the first space shuttle Columbia was unveiled. The head of the Soviet space shuttle program was Valentin Glushko, chief designer at the aerospace company NPO Energia. The plan was to develop an orbiter called the Buran, which means snowstorm or blizzard in English, and its launch vehicle, the heavy lift rocket Energia. The race to the moon ended in 1969 with a US victory, and shortly thereafter, the Soviets abandoned their lunar ambitions. But Glushko held onto the dream of establishing a Russian moon base, and initial Buran designs were tailored with moon missions in mind. But Minister of Defense Dmitry Ustinov made it abundantly clear to Glushko that they were not going to give him his moon base, and furthermore, he would not accept anything less than a close copy of the US Space Shuttle. Work began in 1976, and by 1983, the first small-scale version of the Buran was tested. The Australian Air Force caught sight of a Soviet ship pulling a scale model from the ocean, and rumors began circulating about the Soviet Union's attempts to match the US Space Shuttle. On November 15, 1988, Buran and the Energia rocket lifted off from Baikonur Cosmodrome. There were no crew on board. The shuttle orbited the Earth twice, and on its return, it successfully performed an automated landing on the shuttle runway, a feat beyond the capabilities of the US Space Shuttle. It was the first and only time the Buran would fly to space. In the US, a highly technical analysis began almost immediately after the Buran landed. NASA produced a report on the major differences between the two shuttles. It could as easily have been labeled major similarities. The Soviet shuttle was only 3 feet longer. Its payload bay was only 15 inches longer. The forward payload door was 8 inches bigger. The height of the vertical stabilizer merely 1 inch taller. Some argue that the similarity of the shuttles was because they were designed with the same objective in mind, and the laws of aerodynamics determined the shape of both orbiters. The intelligence community, however, weren't so sure. Throughout the development of the space shuttle, the intelligence community were aware that the Soviets were engaged in what was euphemistically called technology transfer, but they didn't know just how vast and elaborate the Soviet espionage efforts were. In July 1981, just 3 months after Columbia's maiden flight, US President Ronald Reagan attended the G7 summit in Ottawa, Canada. There, French President François Mitterrand took Ronald Reagan aside to share some intriguing information. Mitterrand told him that the French had a mole in the KGB, a high-level colonel. The mole had handed over a mountain of secret Soviet documents which detailed how KGB spies had infiltrated US industries. The source of these documents was Colonel Vladimir Vetrov, a 53-year-old engineer working with the KGB's Directorate T. Vetrov had become disillusioned with the communist ideal, however, and in 1980 he defected and began supplying French agents with copies of Directorate T documents. The French assigned him the codename Farewell. As the Central Intelligence Agency began to analyze Vetrov's documents, labeled the Farewell dossier, it became abundantly clear that the KGB was making up for its country's shortcomings in computing and technology by employing a vast and efficient network of spies. During the Nixon administration, the US government had favored a policy of diplomacy and cooperation known as détente, and the Farewell documents showed that Soviets had taken advantage of this openness by inserting hundreds of Line X operatives into visiting delegations. In all, Vetrov provided approximately 4,000 documents to the French, comprising a collection of data which exposed an astonishing degree of Soviet subterfuge. With the documents in hand and Vetrov's role still unknown to his bosses at KGB headquarters, the CIA devised a plan to take revenge. Gus Weiss, a Ronald Reagan aide at the National Security Council, met with Director of the CIA William Casey and pitched an idea. He proposed using what they had learned from the farewell documents to begin feeding the Soviets information that, while appearing genuine, would be critically flawed. William Casey was enthusiastic about the idea, and critical materials were developed, including several space shuttle related materials based on rejected NASA designs. At this point, the facts get a little murky, but it's suggested that a failure in the Buran's heat shielding can be attributed to false information leaked to the Soviets. When NASA engineers examined images of the Buran after its spaceflight, they agreed its heat shielding had been badly damaged and the shuttle wouldn't be able to fly again. It's believed that this is because the Soviets were given outdated information regarding the space shuttle's heat shielding, but there's no hard evidence of this. Vladimir Vetrov's story doesn't end well. On February 22, 1982, Vetrov met his mistress Lyudmila in a Moscow park. The double agent was on edge, fearful his spying was about to be discovered. The couple sat together in Vetrov's car and began arguing. The argument turned violent when suddenly another KGB officer who had been taking a walk in the park knocked on the car window. He had recognized Vetrov and wanted to say hello to his colleague, but Vetrov panicked and stabbed the KGB officer, who died at the scene. Soviet authorities hastily investigated the case and prosecuted Vetrov. His mistress Lyudmila survived her wounds and testified against him. Vetrov was sentenced to 15 years for murder and was sent to a prison labor camp in Siberia. But the KGB was suspicious. Vetrov's behavior was out of character. The spy seemed to be under immense pressure, and they wanted to know why. In an intercepted letter to his wife, they got their answer. Vetrov wrote to his wife Svetlana and suggested she contact the French authorities to let them know about his situation. It was enough evidence for the KGB to move against him. Vetrov was transferred to Moscow's Lefortovo prison, where, according to former KGB officers, he was tortured and eventually confessed to acting as a double agent. Vetrov was executed in 1983.
One sign the Soviets can make that would be unmistakable, that would advance dramatically the cause of freedom and peace. General Secretary Gorbachev, if you seek peace, if you seek prosperity for the Soviet Union and Eastern Europe, if you seek liberalization, come here to this gate. Mr. Gorbachev, open this gate. Mr. Gorbachev, tear down this wall.
When Ronald Reagan delivered the Berlin Wall speech in 1987, the writing was on the proverbial wall for the Soviet Union. Leonid Brezhnev had died in 1982, and after a period of instability, Mikhail Gorbachev became the leader of the Soviet Union. Recognizing that the Russian economy was in trouble, he launched a raft of sweeping reforms. Perestroika aimed at restructuring the economy, and Glasnost, a policy of openness and transparency in government institutions and activities. Both reforms were seen as a move away from communism and towards democracy. In November of 1989, Gorbachev did tear down the Berlin Wall, and 2 years later, in December of 1991, the USSR was formally dissolved. In June of that year, Boris Yeltsin became Russia's first democratically elected president. It was a time of incredible upheaval. There's a video about it on the channel if you want to know more. And one of the first casualties was Russia's space program. and specifically the Buran. Russia's economy was in crisis. The Cold War was effectively over, and with it, the arms race. In the 70s, Soviet leadership, gripped by paranoia, had overestimated the military threat of the US space shuttle. There was now simply no need for an expensive space bomber. The Soviets had planned to build 5 orbiters, but only the original Buran was ever finished. A second orbiter was almost complete when the program was shut down in 1993. Today, it's gathering dust in Baikonur. The question remains, just how similar are the Soviet and US shuttles? In terms of form and function, very similar, but in many ways, the two orbiters were quite different. The major difference was the engines. The US space shuttle was fitted with huge engines. It would lift off under its own power, strapped to a giant fuel tank, with some additional thrust provided by 2 solid rocket boosters on either side of the fuel tank. As a quick aside, it was an issue with the solid rocket boosters that was responsible for the loss of the Space Shuttle Challenger in 1986. There's a video about the disaster on the channel. The Buran, by contrast, only had small maneuvering engines that would only be used once it was already in orbit. The Buran was strapped to the reusable super heavy lift rocket, the Energia. The Energia was designed to take a variety of payloads into space. The Buran was just one of them. In some areas, the Buran Energia system outperforms the Space Shuttle. The Buran could orbit twice as long as the Space Shuttle. It could also lift 30 tons of cargo versus the Americans' 24 tons. And 10 Soviet cosmonauts could squeeze inside Buran compared to 7 astronauts on the shuttle. The Energia rocket could also take payloads of up to 100 tons into space. At the time, the US didn't have a competing system. After the Energia was retired in 1993, the world wouldn't see another super heavy lift vehicle for 25 years when SpaceX launched the Falcon Heavy in 2018. When comparing the Buran to the Space Shuttle, it's important to remember that the Buran only flew once, so it's difficult to make a fair comparison. Over the lifetime of the Space Shuttle program, from 1981 to 2011, a total of 135 missions were flown, with the loss of 2 shuttles, Challenger in 1986 and Columbia in 2003. The Buran program was officially scrapped on June 30th, 1993 by President Boris Yeltsin. At the time of its cancellation, 20 billion rubles had been spent on the project, and what remains in Baikonur serves as a monument to Cold War paranoia. Thanks for watching, and make sure to take a look at some of the other videos on the channel.